Okay, and in this video we're going to continue our investigations of polynomial functions in section 4.1. We had completed the first two examples. We're going to take a look at the third example here. H of x is equal to 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. Our degree here is the lead degree, which is 4. Our leading term is 2x to the fourth. Our constant term is negative 18. It's the one at the end. This is an even power, and it's a positive here, so that means it's going to look like a parabola with something in the middle going up on both ends. It's positive. It's going to kind of look like a quadratic because of the power e being even, but there's going to be something in the middle we're going to graph and see that stuff. So the end behavior is going to match this kind of graph. So we're going to be going up from on the left hand side and on the right hand side, so we can do that. We can also tell it's even, then odd, then even, then odd, then even. So that means it doesn't have any symmetry because some of the powers are even, some are odd. So if we have all even powers, then we're going to have symmetry. If we're going to have odd powers, we're going to have symmetry. So let's take a look at the graph and see if we can find this information out. Remember last time I had the graph all set up. So it's still there. We've highlighted the third thing. We're going to zoom, start with our standard viewing rectangle. We see this. Okay, so we see most of the graph. We have to go down quite a bit further on the y, so we need to change our y minimums to decrease. So I'm going to go down to negative 30 first, and we're going to scale it up by 3 so we don't see as many marks. We'll look at the graph there, see what we see. We still don't see it all, so I'm going to make my window a little bit, go down a little further. So I added 20 last time, let's add another 20, negative 50. I'm going to scale it up by 5 here. So it still has about the same number of marks. So we have a graph that looks like this. All right, so we can get the number of turning points. So one turning point, it decreases, then increases, that's 1. Then it increase, decrease, that's 2. Then there's 3 turning points. So we have 3 turning points there for sure. So right now we have 3 turning points. We have 1 x-intercept and 2 x-intercepts, but I can't really tell right there how many x-intercepts I have, so I need to zoom in on that area. So we're going to use zoom and in to see if we have any x-intercepts. Now we're going to move the cursor up. It's at 0, negative. We want to move it up close to that point where we think it might zoom in. Okay, and then we push enter. So it's cursor right here. It's blinking right there. Push enter. So it looks like we have 1, we see that one, and it looks like there's 2 more right there. So that means there's 4 intercepts on this graph. So we're going to put down 4 intercepts. Okay, we're going to zoom back out to see what the graph kind of looks like. Okay, so we're going to do zoom. And if we go to memory over here, we can do zoom previous. That'll take us back to the same window we had just before that, zoom previous. So that might be something new you didn't know before. These are all the zooms, but we also have a memory of zoom previous. So I'm going to do that. It's going to take me back out to my window that I had before. All right. So that means my x minimum was negative 10, my x maximum was 10. My x minimum was negative 50 and my x maximum was 10. So this is kind of what my graph looks like. It goes down through about 1, 2, 3. So we're going to go down, come up, go down, come up, just, whoops, edit, undo. So we're going to come down. We'll go up, it crosses here, and it goes back down and then back up. It kind of looks like that. Let's do a little bit better job. Okay, comes down, crosses, goes back up, crosses, It goes down, crosses a little lower, and then goes back up. This looks like a little bit better of the matching of the graph there. Yep. Okay. So that's our graph. Now I want to summarize some of the things we have here. So the degree of the term is the highest. It's lead term degree. It's the largest. Okay, the leading term is the term with the largest degree. The constant term is the term with no variables. And behavior is going to be as function moves left or right, what happens to f of x? Okay, does it move up to infinity or down up to infinity or down to negative infinity? So what does it do there? Number of x-intercepts. On a general thing, it's going to be, there's going to be at most n, which is the highest power. So if we have a degree of at most n, and this is the highest power or the degree. So if we have a degree of 5, we have at most 5 intercepts. We're going to have less, but we have at most 5. And the number of turning points is at most n minus 1, 1 less than the degree. And we can't tell that until we've graphed it, how many turning points it actually has, but we can say at most we have, if the degree was 5, we have at most 4. And if we look at these examples up here, you can see this one had a degree of 3, and we had 2 turning points, 1 less. Although we didn't have 3 intercepts, that didn't match there, we only had 1. But at least on this one, it actually matched the maximums. We had degree 5, and we had 5 intercepts, and we had 4 turning points. So this one really matched the maximums of the degrees and the turning points, the intercepts and the turning points. And this one also matched the maximums. Degree of 4, we had 4 intercepts and 3 turning points. So the last two there actually matched the maximum number of x-intercepts and the maximum number of turning points. Okay, so symmetry is if we have even or we have y-axis, that means it folds over the y-axis, then all exponents must be even. Okay, and then with odd, this is origin symmetry. All exponents must be odd. So we can look at the exponents and say whether it's odd or even by looking at them like we did here. So we had 3, that's odd, 1, that's odd, 0, which is even, so this was neither. And so this one had 5, 3, and 1. Those were all odd, so we can say odd symmetry. That has origin symmetry as well. Odd and origin symmetry. This one would have neither because it had some even ones and some odd ones. So that's a summary of the information from 4.1 on investigating polynomial functions.